1-9, graphing linear function. Okay, thank you. Linear function. What's linear mean?
Linear.
Line.
What? What's linear? What word is in linear?
Line.
Line. So it's a line. What's function mean?
It doesn't repeat. Yeah.
What doesn't repeat? Okay, good. Okay, good. So a linear means line, but function, yes, it means x's don't repeat. Good, I'm glad you know that. What else does function mean?
It means it'll go past the vertical line test.
Yes. Yes, okay. There's another word for function.
Function.
That's all right, but I'm looking for the other definition of it.
What?
Do you have headphones on? Okay. Okay. Function means an equation. It's a fancy word for equation. Remember that? Okay, so a linear function, what's linear mean? Line. What's a function mean? Equation. So it's a straight line equation. Okay, so function, a linear function is a function. So what's function mean? Equation. It also means x's don't repeat, but in this case, the definition means equation, okay? So a function whose graph is a line. Is a line. So it's an equation where the graph is a line. Straight line, okay? Okay, so it says examples. Given the following domain values, find the corresponding range values, then graph the function. Okay, so what keywords are here? No. What are my two keywords? Domain and range. So what do I need to write? Dr. XY left his ID in his office. Okay, and domain stands for what? X. So I'm going to go underline domain and put an X. What's range? Y. So I'm going to underline range and put a Y. So it says given the following X values. So what does it give me? The X's. Everybody see that? Yeah. Find the range. Do I know the range? No. I don't know my Y's.
Yeah.
Okay. So what are these? D stands for what?
What?
My X's. So these are all X's, right? Go put an X above all of them because they're all an X. And how do I find the range? What are we going to do? This is kind of review right here.
Football game.
Good. We're going to play our football game. Which part is my football game?
The X. The equation.
This part right here.
2.
Very good. That is my game right there. Okay, so we're going to take each bench warmer, right, all my X's. We're going to plug them into the football game. And who's playing bad?
Kansas.
Kansas played bad, yes. Who's playing bad in this football game?
9.5 hours.
Red Raiders.
Okay, stop.
Red Raiders.
Okay, I get it. Okay, we're throwing tech jokes. I get it. Okay. Who's playing bad in this equation? The X. Okay, so who's got to come out of the game? X. All right, so I'm going to take each bench warmer, and I'm going to plug it into the game and get my answer Y. All right, so everybody have a calculator. Everybody got one? If you don't have one, get one like me. Okay, go to a calculator. Now, add calculator. All right, we're going to plug in. What are we plugging in first?
3. -5.
-5. So -5 is going to go into my game, right? But the only thing that comes out is what?
X.
X. X is the only guy that leaves. And when they go into the football game, what does -5 have to have? It's got to have his helmet, his parentheses. So I start with 3. So everybody put 3. And then I'm going to plug -5 in, so he's got to have his helmet. -2. It's not -2. It's -2.
Equals
Enter.
negative.
And I get what?
-17.
And that's my representing what? What is that?
Y.
My Y. Good. Okay, so now negative 17. Remember, we're listing numbers because I'm about to list all my y's here. I'm about to list all the answers, so I got to have a bracket, and my first answer is negative 17. Now, when I took 5, my x, stop. When I took my x and plugged it into the equation, it gave me my what? The y. So when x was negative 5, what is my y? Negative 17. Oops, that's a bad 7, but that's okay. That's negative 17. Okay, now we're going to go to our next bench warmer, which is negative 4, right? So we're going to go to our calculator. Everything stays the same except I'm going to put a negative 4 for x. So 3. And then I'm going to plug in negative 4 into the game. So he's got to have parentheses. Negative 4 minus 2 gives me negative 14. So he's my next list of number. And negative 14 represents my what letter? Y. So when x was negative 4, my y is negative 14. And then I'm going to sub in my next bench warmer, which is negative 1. And when he goes into the game, he's got to have a helmet on. Minus 2. Does everybody see where I'm plugging it into this equation? Instead of writing x, I put the number, the bench warmer. And I get?
Negative 5.
Negative 5. Good. And that represents my y. So when x was negative 1, my y was negative 5. Okay. Then I plug in 0 into the game, minus 2. And my answer is negative 2. And when x was 0, my y is negative 2. Okay, now we're going to plug in 1, bench warmer 1. Number 1 is 7 into the game. He's got to have his parentheses on, his helmet on, minus 2. And I get positive 1. And that's my y. When x was 1, y was 1. And then I plug in my last number, which is 3 into the game. 3 times 3 minus 2 gives me 7. And that's my last y, so I need a bracket. And when x was 3, y was 7. Okay, what's this called over here? A table, right? Okay, a table. What are these? This. They're my what? My y's, which stands for R. What's the R stand for? Range. Range. These are my range. These are my domain. This is a table. Okay? Then it says we are going to use these ordered pairs to help us graph this linear function. What's linear mean? Line. What's function mean? Equation. So my line equation. We're going from we're going to go from discrete. What's discrete mean?
A line. 2 dots connected by a line.
Okay. It's just dots on a graph, right? So we're going to put a bunch of dots on the graph. So we're going to start with discrete, all the dots on the graph, to a continuous. What's continuous mean?
2 dots connected by a line.
A line. Good. So we're going to go from just dots, and then we're going to connect the line. Got it? Questions? Okay, so let's plot these points, all right? All right, here we go. So I'm going to start with negative 5, negative 17. So here's my graph. First, we're going to label our x and our y. Okay, so my first x is negative 5. So I start in the middle. I'm going to go backwards 5. 1, 2, 3, 4, 5. Then my y is negative 17. So I'm going to go down 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it would be somewhere down here. I'm not going to worry about that dot. Okay, I'm going to go to the next one. Negative 4, negative 14. Is it going to be there? No. Okay, well, if I was to plot it, I would start in the middle, and I'd go negative 1, 2, 3, 4 for the x, and then down 14, but that would also be off the graph, so don't worry about that one. Okay, now this one will -1, -5. Negative. Go down 5 for 1 and put my dot. There's my. Then we're going to go 0 on -2. Then I got 1, 1. So start in the middle. I'm going to go 1 right or on the X and then 1 on the Y up. Then 3, 7. So start in the middle. Go 3, 1, 2, 3, up 7. 1, 2. Good. Everybody got those dots? Discrete graph, right? It's just now we're going to make it a continuous. Boom. Okay. It is a continuous line. I want to know the domain. X, Y, left is I. Tell me that domain stands for Y. Okay, now how? Very good. X less than. Why do I start with X less than?
Because there's.
Because you learned it, yes. But how do I know on this graph? Because it's continuous. Very good. Because it has a line. If it was just scattered dots. Okay, but because it's continuous, now I need this. We're going to do our X. The X is what we're talking about. Let's go side to side. The very.
No.
What is it?
Negative.
It's an arrow. So can I write a number for an arrow? No. What's the last thing I touch?
Arrow.
Arrow. What if I have 2 arrows? What does that mean?
But you got dots
numbers.
All. So cross it out. I need all real numbers. Or the symbol 2 lines and an R. Okay, let's look at our range. How would I start this for range? Same is how I would start it, correct? Because it's continuous. Now if I get on my
Arrow.
what's the last thing I touch? All numbers. Do I need this? No, not on this problem. I don't. And then my symbol. Okay, so if it wasn't 2 arrows, then we would do X less than, and Y less than. Okay? But because. Okay, look at these. Graph above. Okay, I'll figure it out in a second. All right. With this, could I draw? It only hit 1 time. Yes. Would all linear graphs pass the vertical line test?
No.
Would all straight line graphs?
Yeah.
Well, what if they're like up and down?
Okay, let me do this.
Straight line.
Straight line.
If it's a straight line, it will pass it.
Okay, here we go. I'm here with this. Boom, shakalaka. All right, so let's say here is my axis, right? What if I had a line that looked like this? Would that pass the test? Yes. What like this?
Yes.
Kind of like this.
Yes.
What if I had
No.
Yes.
No.
Would that be a vertical? Would that be past the line test?
No.
No, because they all touch each other.
Yes, you're right. Dot on this same x is 1, 2, 3, 1, 2, 3, 4. 3, 4. If I plot this point, this would be 3. This one. They all have. Would that pass the vertical line test? No. Test. No. Every vertical line except the up and down one. Vertical line except the up and down one. Because it doesn't. Will a line ever have a numbers?
No.
No.
Doesn't have an arrow.
So if you had this graph right here, the vertical line, does it?
No.
No. Line. So for domain would be 3 because every x is 3. So would that be all real numbers?
No.
So would a line numbers? Yes. Vertical line. Actually, line because that's the example. Will a line ever have a range which is not a set of all real numbers? What if I had a horizontal line that went like this? My touch is the line, the last. So it's the same thing right here as the vertical line. The same thing for range is for a horizontal line. So yes, you could have it not have all real numbers. It would just be one solid number, wherever this is. All the y's would be the same. Questions?
Oh, that's good.
Okay.